Today we're going to take a look at section 1.1. It's titled Real Numbers, and we're going to define what real numbers are and what some sort of subcategories of real numbers are that you've experienced before. So to start with, we've got this gigantic diagram, and what we're actually going to do is we're going to start in the very center of the diagram with that little bitty square. Okay? That little bitty square represents the numbers that you first learn when you first learn to count. So what are the first numbers that you start when you're starting to count as a 3-year-old, 2-year-old, something? 1, 2, 3. Yeah. So those actually are called the counting numbers or the natural numbers. So the natural numbers is in the middle here. You can also write counting numbers next to this if you would like. And the natural numbers, let's see if I had that in there, are like 1, 2, 3, and we will put ... They continue on. So very quickly inside of your world, you find the need for an additional number, and the first additional number you find a need for is usually 0, right? You need to figure out how you represent not having any more cookies because you ate them all, right? So once you need that additional 0, we actually have what's called the whole numbers. Now, the whole numbers include the 1, 2, 3, 4, and so on, but they also include the number 0. So we're going to write them as 0, 1, 2, 3, ... Okay, so the way that this picture is sort of created is that you can see natural numbers is a category inside of whole numbers. Okay, but all of these natural numbers are also whole numbers. After that, you have the need for something called integers. Do you know what integers are? Anybody remember? Includes negatives, yeah. So we're going to include negatives. That's going to be our integers category. So we actually will put the ... over here, and it includes all the positive and negative whole numbers, and then also the 0. So tell me, what have I not included so far? Rational and irrational. Do you know what rational numbers are? Do you remember? Okay. Anybody else remember what rational stands for?
Real number?
So these are all real numbers. In fact, I should write that up here, or I did, actually. Real numbers. These are all real numbers.
With decimals, right? Yeah,
decimals and fractions. So the root of the word rational numbers is the word ratio. And ratio means it's a fraction. It's a comparison of things. So we can't write a list like I did with the other ones, but I can give you some other examples of things that are now included as well. So it includes things like 1/2 and values like 0.623 and also things like 0.7 repeating. Now, it's important to note that it's not just numbers that look like this, right? Rational numbers are also everything else that's embedded inside of this square. But what it really is, it's anything that can be written as a ratio. So consider the number 3. How do you write 3 as a ratio? 3 to 1, right? 3 over 1. So I can write it as a ratio of whole numbers. Therefore, it is a rational number. So everything in this sort of left-hand quadrant over here, or the side, half, if you will, is actually a rational number, everything I've listed so far. And you mentioned irrational numbers, and that's the other side. So it is not meant to sort of look like there's this even split or anything. You know, it's not like there's just as many rational as irrational. It's just a diagram. There's no size involved here. It's just sort of creating categories. What numbers are not on here yet?
Negative.
I already have negatives. The integers were negatives. Pi. Pi. You're right, I is not on here either, but I is actually not a real number. We will talk about I, but it won't be for a while yet. I is an imaginary number, so real versus an imaginary, and I don't mean imaginary meaning like imaginary friend. It's not like that. Yeah, I is not on here, you're right. Anything else that you can think of?
Isn't it like numbers that
So variables, but variables aren't numbers. They represent a quantity that changes. You're right, that's not on here. What else?
numbers that don't conclude?
Numbers that don't what?
Don't conclude, like don't end.
that don't end. Okay, so what we would call those is non-terminating and non-repeating. Okay, so you have things like, here's an example, square root of 2. If you were to put square root of 2 like into your calculator, it would spit out a decimal approximation, but it's just an approximation, right? It like never repeats, because we do have repeating, they're over here, and it never ends, so it never terminates. So all of your radicals that are not perfect squares would be included. There's actually one more number that you may have encountered that's over here. You seen E before? We won't do anything with E this semester, but you will in college algebra. If you were to ever take contemporary math, we do it in contemporary math. E is about 2.718. It's approximation for it. But again, it has the same features that I does, or that pi does, right? Where it doesn't terminate, doesn't repeat. Same features as square root of 2 does. So those are irrational numbers. They cannot be written as a ratio of integers. So some of the questions you have might be asking you to compare, like tell what kind of numbers these are, or to give examples of types of numbers. That's the kind of thing that we're going to be looking at. A couple other things in this section we're going to talk about is graphing. So we're going to look at number line graphing. I want you to remember that we read a number line from left to right, smallest to largest, just like we read English. So what you're going to experience when you get your homework is you're going to see these kind of lines already drawn, and they're going to have like decimal hash marks in them already. Okay, so they're going to be a little bit more structured than my picture is already on my screen. But we're going to graph 2.3 on a number line. So 2.3 is in between 2 and 3, right? It's like $2.30. So we have the number 2 here. And then I'm going to do like tick marks in between for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the number 3. So if you were to start this particular problem on a homework, it would actually start out looking like this already. A little bit bigger. And it would ask you, plot 2.3 on the number line. And so you would do so. You would count over. This is 2.1, 2.2, 2.3 right here. And you would put a dot there. Okay? All that we're doing today should be familiar things. I'm not trying to teach anything new. That's not the goal. Just reminding. The next one actually already has a location on the number line, so I'm going to draw this in. And again, it would already start out drawn in if I had been giving you like the homework problems. But so 2.2 is the beginning, 2.3 is at the end, and we're going to have a dot showing up right here. And the question is, what is this location? Call it A. I know you're kind of far away from the screen. It'll be easier when the paper's sitting in front of you, but can you figure out where I put the dot? How many tick marks in did I go? 6. Right, so this dot, though, is not at 2.6, right? It needs to be between 2.2 and 2.3. So what is that location?
2.26?
Right, 2.26. We have to go to the hundredths place in order to identify what it is. Again, if you want to think about it in terms of money, 2.2 is like $2.20, and 2.3 is like $2.30. We need to be between 20 cents and 30 cents. It's 26. Okay, so far so good? Mm-hmm. All right. The next topic we're going to remind you about is inequalities. So inequalities are a statement that is using the symbols listed here. There's 5 symbols, and I'm going to define what they are to remind you. The first one is less than. Sometimes I know people like to sort of turn it on its side, right? Just angle the less than, and it looks like an L to remind themselves. That's a less than symbol. The one right beneath it is greater than. We're going to go over to the right-hand side of that. So if this is less than, and you put a line underneath it, what does that mean?
Equal to.
Yeah, it means or equal to. So this is less than or equal to. which means the next one underneath it should be
Greater than
or equal to. What's this symbol?
not equal.
Yep, that means not equal. We don't see that one used quite as frequently, but to leave it out seems not right to me because it is a symbol for inequality. So we have an example, and what we're going to do is we're going to put a symbol in between it. There are actually two symbols that could go in between it and be correct, which means you could pick either one of them and finish the statement correctly. So which symbol could go in between? 6.21 and 6.13. What do you think?
Greater than?
That's one of them. What other symbol could go in between?
Greater than or equal to.
Yep. So you can do that one, or you can do the greater than or equal to. They're both correct, right? Interestingly enough, and the reason we bring it up, you can actually, although it feels kind of funny to do so, do this symbol here, right? It feels weird because it's just equal to. Or you could do this symbol here and it would be okay. So just make sure you're paying attention to the options you're given, because sometimes they give you choices to put in there, and sometimes they just tell you to put something in there that would work or whatever, and you have lots of flexibility. Any questions about that? Okay, we're about to do maybe the only part when you do your homework that's going to require you to show work. Everything we've done so far is almost like filling in the blank stuff, right? It's right or it's wrong. And when it's graded that way, it's just going to be graded right or wrong. The next part involves you to show work. So we're talking about square roots. A square root is one of two equal factors of a number. So, for example, let me do principal square root first. The principal square root is the non-negative square root of a number. So we've got an example of square root 64. If I were to have asked you this without even defining the non-negative part, you probably would have told me the non-negative part. What is the square root of 64?
8.
8. And the reason is because 8 times 8 is 64. So whenever you see this symbol, the radical symbol, it means tell me the positive answer. Now, you might be thinking, well, what about negative 8? I mean, negative 8 times negative 8 is also 64. And it is, right? And in fact, in high school, you probably came across times where you had to put like pluses or minuses on things. You guys know what I'm talking about?
Yes.
Okay, so that happens when we're solving algebraic equations, and we will get there eventually. But when the symbol is already there, right, the square root is already there, it means the positive answer. Without question, okay? It's only the positive answer we're looking for. So our value here is, in fact, 8. Now, not all values have fabulously perfect square roots, right? 64 was lovely. 16 is lovely. 36 is lovely. 34 is not. 12 is not. So what we would like to be able to do is we'd like to be able to combine things and figure out what is and isn't what's called a perfect square root. So a perfect square root is a number with a square root that's a rational number. That's an example of what we just did. So some examples would include 25, 81. Somebody tell me another example of a perfect square root. 64, the one we just did. Yeah. 36, 16, about 100. There are lots of perfect square roots, right? There are. But there's actually more things that are not perfect square roots. So some non-examples would be things like 34 and 12. I mentioned those. Tell me some other things that are not perfect square roots.
22.
22. Let's go with a couple more.
11.
11. 7. Yeah. If you try to take the square root of any of these, you don't get a perfect rational number. And most of the time, we're looking at things that are actually integer numbers or whole numbers. So what about this number 20 in our last example? Is 20 a perfect square root? No, it is not. So the question actually asks us to find two numbers that it lies between. right? Like if you stick it in your calculator, it's going to tell you 4 point something. It will. I'm not going to, like that's not a mystery. So my goal is not for you to take square root of 20, stuff it in your calculator, it to say 4 point something, and you tell me, well, clearly it's between 4 and 5. Okay, yeah, because your calculator told you that it was 4 point something, now you know it. That's not the point here. The point is that there are perfect square roots around the number 20, we're going to put 20 right here, that are perfect squares. What is this perfect square that comes right before 20?
16.
16. And what's the perfect square that comes right after 20? 25. Okay, so 20 is sandwiched in between these two perfect squares, right? It is. So when you are doing this problem, I expect 16 and 25 to show up somewhere in the work. Your point is to try to figure out what are the nearest to this value perfect squares. Why? Well, because then you can actually take the square root of them. What is the square root of 16? What is the square root of 25? So we'll start with 16. What's the square root of 16? 4. And what's the square root of 25? 5. So what does that mean? Well, it means that the square root of 20 is somewhere in between, right? 4 and 5. So our answers are 4 and 5. Not because the calculator told us that the square root of 20 is 4 point something, but because we analyzed nearby perfect squares, namely the 16 and the 25. If you simply tell me 4 and 5 and don't show the nearby square root value, the perfect square values, you're not going to get full credit, because I'm going to assume that you probably thought about it from the calculator standpoint, especially if the value is larger than 20. Any questions on that? All right.